Hello, how are you doing?
Hi, how's it going?
Thanks. I just uploaded the updated lab document. I ran into a little bit of issues when I retested the lab, so you want to download it again if you downloaded it earlier.
Is that the big file that you have to download?
On lab 2, it's just the document for just the instruction. You can view it within, but I just want to let you know that I uploaded it.
Okay, thank you.
Yeah. The big file that you need to download is the virtual machine. That might take a little while, or you can make your own. And so I'll walk the class through on how to make your own virtual machine, okay?
Okay, I already downloaded it.
Okay, good. Hi, everyone. How are you doing? Okay, so I just uploaded the latest lab document. Thank you for answering my questions. So if you wanted to download the virtual machine, you can. I reshared that with my Google account. And then if you want to make your own virtual machine or use Kali, if you're familiar with that, you can. But I will walk you through the process on how to make your virtual machine. Okay, so let's share screen real quick. Okay, so this is going to be our lab. Sorry, I had to change some stuff recently because there are, of course, some changes with Python packages. And so the first part is just to walk you through how to make a virtual machine in Ubuntu. Okay, so you can make your own, or if you want to download, you can. And this might take a little bit because it's coming from Google Drive. It depends on your connection and also Google Drive server. So now if you want to make your own, you would need to start with the instructions. Okay, let me pull up my lab. 1 second. So for your lab, the login, if you download, is the user account is student. It should prompt you that, and then the password is this. But if you want to make your own, you would need to use VirtualBox. And even if you don't make your own, you would need to have VirtualBox installed on your system to play the virtual machine that I released. So the first part is to install VirtualBox. So A is required. Okay, so you can visit the website. And then once you're on the website, you would select the right release for your operating system. So I'm using PC. I'm going to go ahead and click that. If you're using Mac OS, you would click this. Or if you're using Linux, you would choose this. Okay. So this would allow us to download Oracle VirtualBox, which is used as a player to play your virtual machine. So once you have that, let's say, let me demo it. So make sure that you know. So I'm on Windows, I would download and it's going to give me the executable. I would then go to my downloads folder. And once that's ready, it should be a few seconds left. I would be able to see that. So it would be this application. then you would double click it to run, and you simply install with the default configuration, the selection that it has there. Okay, so it would be in your downloads folder. Now that is required to run our VirtualBox. So then what you would need is you would need to create your virtual machine if you didn't download. So to make a virtual machine, you would then call VirtualBox. So in my Windows PC, I would search for VirtualBox, which comes up right here. And then I would open it. Now, when you don't have your virtual machines linked to the player, you would see that it would not have any of the ones on the list. So what you will do is you would start with the new. And what I would recommend is it's going to default to a folder. What you can do is you can point it to a specific folder. So would click down the drop down menu and choose other. And here is where you would put it on your desktop or something like that. So I'm going to go ahead and put it on my D drive. And I'm going to make a new folder called CIS30E VM, for example, and I can put 22 so I know which one. So however you want to name your virtual machine, I'm going to go ahead and choose this and select. But you got to give your VirtualBox a name. So we are going to, so on here, you can say CIS30E VM for lab, for example. Now, the versions that I can use is not that important yet, but you can also select Linux, and then you can use Debian 64-bit. Okay. Now, in order to proceed on the lab procedure, it tells you that you also need to download the ISO, which is an image file that allows us to create an operating system that can be played inside our software. So we use our Windows to access VirtualBox, which is going to show an operating system within. So to download Ubuntu ISO, you are going to visit the Ubuntu website. The link is provided on the lab. And you can simply click download for 22.04.01. And once that's downloaded, and it tells me that it might take a while because, you know, depending on my connection, but it will also put it into your folder, okay, your downloads folder. So after you downloaded your ISO, you can give it a name and the default path for your virtual machine. So whenever you need to find it, it's gonna, for Windows PC, it's gonna be there. But I would recommend to store it onto your, another folder, another location. Now, if you try to put it on an external USB, it's going to tell you that because the USB is FAT or file allocation table by default, it might not like it. So you have to format your USB in like to an NTFS or something like that for PC in order to store it. Okay. There's some challenges with cloning also from USB, so I would recommend storing it on your computer first, and then you can clone it and move it to another location. So as you proceed, let me come back to VBox because I actually have one that's running. So when you click new, you would name and then you would point it to the location. Let's say you Ubuntu VM, or you can name it CIS CIS30E, Ubuntu, whatever you want. Okay. And then you would browse to the location where you would have it. I think I did this step earlier, but let me come back here. So I'll put it in virtual machines. And then it automatically should detect, or you can change it to Linux, Ubuntu 64-bit, and then we can go next. Now this is important. The more RAM you give your virtual machine, the faster it's going to respond. So in my case, I actually have 16 gig on my laptop. So I want to make sure that I would give it at least 2 gigs. So you can change that here to 2048. That will be 2048 megabyte, equivalent to 2 gig of RAM. If you want to give it more, you can. I think with 2 gigs is pretty decent. So you can click next. Okay. Now, it's going to recommend as 10 gig. This is pretty small because as you proceed to this class, you're going to find that 10 gigs is not going to be enough when we run the larger applications. But what we can do is we can proceed and then we will be able to modify the drive size. So this is the process that I went through to create your virtual machine. So I just want to walk you through it so you know. So click create. It needs to make a virtual disk image so that way it will be able to write the OS file. So we're going to keep it default with the VDI and go next. And you want your disk to be dynamically allocated instead of fixed size. So we're going to proceed, go next. And it's going to make the image and it's going to put it inside the folder where we store our virtual machine. So here is where you're going to change. So I would recommend 50 gigs or higher. So a 50 gig drive for virtual machines is roughly about 12 gigs in a realistic physical space on storage. So that won't be as much because it is a virtual machine. So you can even go 80, but I think 50 is good enough. But don't use 10 by default because it's really small. Then you can click create. Now, we're not done. All we're doing is we set up the storage drive for the virtual machine, which is this right here. And then what we need to do is we're going to go ahead and click start. At this point, you have to point to the ISO file that you have downloaded. Okay. So you would then need to attach it. So click add. And then go to downloads and then find the ISO that you downloaded in my downloads folder and then click open. So what that does is it's going to add the file and then you got to click it and you're going to do choose. So in order to make the operating system for the virtual machine, it needs a .iso file and you can find that from the download. And then you're going to click start. Now you can run as many virtual machines as your system RAM and processor would allow. So in the case for me, I have 16 gigs. So I would be able to dedicate 2 gigs of RAM for each. So I can go up to quite a few, right? If I run 4, that's going to take up 8 gigs of RAM. And so the more you run, the slower your system would be running the overall applications. So if I have 32 gigs of RAM, I can go to at least 10 or even more. So simply when it goes through here, the process is really simple. So the little pop-up that you see is that it tells me that once it loads, VirtualBox is gonna capture my mouse inside the actual window, right? And when your virtual machine is running, it's going to tell you which one is running. And you can always remove the virtual machine by right-clicking it and then remove, and it will give you option to also delete the file in the storage, or you can keep the file, you just remove it from the list. So as I was using the demo yesterday for my other class using Kali, right? You know, you can see that there are different virtual machines that you can use. So this normal process for the installation would be about 20 minutes or so, depending on your processor. Now, if you have an older processor, anything before i5, you will not be able to virtualize. It needs, for the Intel system or the Intel processor, you need to have VTX in order to virtualize. And for the AMD, anything before A4 is not able to virtualize. So all the newer processor, you will be able to do that. So if you're thinking about using an older system, it's probably better just to install Linux on it versus using the virtual machine on it. Okay. Now, if you're using Mac OS, you can still do the same thing. You would download the ISO, you would download and install your VirtualBox manager and be able to proceed with the process, and it would give you the same interface. So I wrote down the instructions. So once you have started the virtual machine and selected your ISO, you would see when it loads, you're gonna see the welcome screen, and then it's gonna select your English keyboard, but we are US English, that's different than the UK. And then you are going to continue to updates. That's gonna take a few minutes. And then it's gonna walk you through and you would select install now. At one point, it's going to stop and it's going to ask you for time zone. It should already select Los Angeles based on your network connectivity. So you can keep it the same and then click continue. And then eventually we will create a password for the and a username. So with that, when I did your virtual machine, I simply put student and then the password. So as you hear the little bell, you would see, so at this point, right, it loaded, it booted. So I would have English and I would click install Ubuntu and it would tell me the keyboard is US English. So I would click continue. And you can have it download updates while installing, but if you don't want to bog it down, you can use, other options. So I normally keep it the same. Linux likes to get regular updates because, as you know, developer, they release new versions with fixes. So you want your Linux system to be regularly updated. So the rule for using Linux is that whenever that after you installing software or before you installing software, you should update. And sometime you should upgrade your OS. Okay. And so what it's saying is going to erase my current storage that I use for Drive. So that's fine. I don't have anything on that. So I'm just going to click install now. And it's going to create sections under Drive. This is the file system that you would see for Linux. And then the second partition here. So it's going to create several partitions. And it's going to use those as drive volume to be able to load Ubuntu. So we're going to click continue. And this normal process, depending on how fast your system would be, like I said before, about 20 minutes. So it's fairly fast, actually. So we have Los Angeles as so now here is where you put in your account. So I can put student, and then I can put in the password. And then I want to confirm that. And we can change it. If you don't want to use the password and just have automatically log in, which reduces the security, you can select this option, right? But you will need to know the password, as the user account that you're creating is a regular user account. It is not a root level account or the higher level account. So at time when we installing system packages, it's going to ask for your password. So make sure that you know your password and click continue. So after this, it's going to proceed to do the install as it's already set up the disk. Okay. And so you would just let it go for a bit. And it's going to ask for updates at one point. Now, to get some of the package to work for us, we would see that we would need the KDE development package. It is not the KDE desktop. You can install the KDE desktop, which gives you a different look and feel for your operating system in the virtual machine. So the Ubuntu is usually you see like a brownish, orange, purplish color. When you install Plasma, KDE, that's the current version, you would see that it changes the desktop to be like a bluish and very beachy theme. So all it is add additional resources. So what I did was I modified the instruction because last year when I did this, I had to install the desktop, which takes a long time and it just takes up a lot of space. So this time we're only gonna do the packages for KDE. I also add in PyCharm for you. So in the case if you want to use PyCharm within the virtual machine, you can. PyCharm is an IDE that you can use with Linux. And here you can see that I chose the classic version. So when you run the commands in terminal, and I will show you what the terminal looks like once your system finished installing, you can run this. So sudo stands for super user do because we're on as a regular user student. We want to have elevated privilege, so we would use sudo. Okay, so these two lines, you do them separately. So after that, I will press enter. The double ampersand here, basically that just allows you to combine two commands into one line. You can also use a pipe to separate. So basically I'm installing the resources and then I would push an update. After that, I would do a build that dolphin, which is part of KDE. So after this, I press enter. Then I type in the next command and I press enter, make sure we don't have typo. And then if I want to install PyCharm, I can. So if you downloaded that virtual machine that I released, you already have this already made, so you don't have to make it. Okay. Any question? So when I previously done this, I actually use a virtual environment inside the virtual machine, which is okay. We talked a little bit about the virtual environment. And then I noticed that as I see students struggling with virtual environment, it's good to have the practice of using it so you can contain your packages within that virtual environment for testing. So if you're testing security script or things like that, that's probably good to test in the virtual environment. But since we're already using a virtual machine, I figured, so I omitted the virtual environment just to simplify the process for you. So all the program that you're going to run, it's going to be directly inside Linux. And it just makes it a little bit better in performance. Okay. So Linux, even though it is development friendly, it doesn't come with language packages. The ones that is shipped with most Linux releases is Python 2.7, the same thing with Mac OS. I read that the newer Mac OS actually is shipped with 3, but it's, that's just sometimes that can be also false. So in the case that if you're using Mac OS, you need to make sure that you check your Python version. If it is not version 3, you need to install version 3. I normally recommend uninstall version 2.7 and then install version 3. Okay. So Linux is shipped with 2.7, Ubuntu especially. Okay. So as here is my machine. It's still copying files and install. And I have another machine running, so I can show you. And this is the clone that I released for you. Okay. So how do I load the virtual machine after I download? Okay, I did put down the step for you, but I'm going to walk you through that. So first, you need to install VirtualBox. After you install VirtualBox, you are going to search for it and open the application. You won't have anything here. Okay. So what you would do is you would go to machine and you would choose add. And here is where you would locate your virtual machine. So if you kept it in downloads, you would need to go to download and then make sure that you already unzip it, because I had zipped it when I put it up. Otherwise, it's going to be very large. So make sure that you go to the location where you store your download that is unzipped. Okay. So I'm going to point to my course, and I had made multiple virtual machines. So in my case, I put it in CIS30E. As you can see, I have the clone version, which is a copy of this one. So I can go ahead and navigate to the folder of my Ubuntu VM. And you would want to find the logo with the cube, and that's your VBox file. So you want to click that and click open. Right? Sorry, I have 2-3 things running, but it should be able, after that, then you're going to click start and it should be able to run. So once you have it started, it's going to load your desktop and it's going to look like this. Not like this, like this. So Linux is a little different than what you see. It's very close to Mac OS. So all your system tray stuff is at the top. All my things are on the left. I'm getting an error saying AMDV is disabled in BIOS. Do I really have to go? Yes. So, and you can try this later on. You would need to reboot your system. So your processor doesn't have the virtualization feature enabled by default. So when you go to BIOS, you would have to toggle that on in order to virtualize. Okay. Yeah. Because if you do that now, your computer will restart. I don't know if you're on your computer or on your phone, but so you can try that. Okay. All right. So here's my virtual machine desktop. This is Ubuntu, right? Now you can go to, this is your file manager, and there's some icon and you can put your cursor on it. It will tell you what it is. It has Office Writer. One of the things that you can do is you can enable share. I did that for bidirectional. Sometimes it works, sometimes it doesn't. It also depends on the RAM capability. So here's your apps. And to get through the Python and checking for Python, we would use terminal. And this is the same as running terminal it's very close to terminal in Mac OS. So to search your app, you just type terminal and you should see terminal in the black square. So we would click that. Now you can increase the zoom so you can see better. I normally do that so I can demo, but and then you can also change the preference of the look of your terminal, right? You can make it light, dark, whatever. So to close this, we simply click on the left and close one of the window, and we'll back to the terminal. So the first thing that you do before you install is you always want to update your system. So, and Linux likes that. So you would do a sudo super user do, and it is case sensitive and space sensitive for Linux. So make sure we type things correctly. So I want to push an update, and it's going to ask me for the password, and I type in the password. CIS30E, all capital. And it's going to show things like this. If you haven't updated it for a while, it's going to take a while. Also, it depends on your network connection. So by default, your virtual machine should share the network connection through your either Wi-Fi adapter or your Ethernet adapter. So once it's done, it's going to give you back your path in command line like this. Okay, so what we did here is number 6, we did an update, enter a password. Now, I recommend doing an upgrade, but this is not absolutely necessary because we just installed with the newest version. But if you use it for a while and you want to upgrade it to the next release or the next version, you can do it. So you don't absolutely have to do this. And this might take a while, depending on the connection and your virtual machine. Okay. So this Y right here, simply pre-answer, because when you do an upgrade, it's going to prompt you yes or no. Are you sure you want to upgrade? And when you type in the switch Y, it just pre-answer that yes. And so it will do the upgrade. And this takes a few minutes or longer. What we want to do is we want to check our Python version. If you don't have Python installed, when you type in Python, it's going to tell you Python command is not recognized. Okay. Anytime that you want to check Python, whether it's version 2 or 3, you can do a Python with a -v, or we call that the switch v for version, or you can do like this, -- version. So I'll do a -v. So as you can see, it tells me that my Python is not found, right? And that means that I need to install it. So when you see, if you want to make sure that Python is there, we want to make sure that it is found. Okay. So that means that if we write our script, we won't be able to run it because there's no Python. So if I want to check which version of Python, right, I can do a Python 3. And I have Python 3. So when you're using Python in Linux, sometime it would say, oh, are you referring to version 2.7? If you have Python 3, right, it's going to take you to the shell, which is this. Whenever you see the triple arrow, you're in shell. So to exit shell, you do an exit function, exit with the parentheses. Okay. And then I can clear by typing clear. So I checked, and I do have Python. I think I finished building that, but it didn't finish. So I'm going to walk you through how to get Python 3. And I think Noah went through this with me when we did the Raspberry Pi. It's the same procedure. So we are going to visit the Python website through the terminal. Anytime that you use wget, it is a way to load a website on command line in Linux. So what we're going to do next here is I'm going to shrink this. And I'm going to put it here so you can see it together. Okay. So we are going to do a wget, which allows us to visit the site, and we are going to go to https www.python.org/ftp, and they release the file through their FTP website, which is what you see on the interface when you click download. And I want to put in the version I want to download. Now, if they updated the version and you know, if you're using like 3.7, that's okay. 3x, anything above 3.6 should work. 3.8 is one of the most stable version before this one, but I think they're at 3.10.6 now. Okay, so I'm gonna do a 391 Python dash, and you want to download the zip file because it's gonna come down as a zip file. TGZ, anytime you see the .tgz in Linux or Mac, I think Mac you have to download the package, but the PKG file. So this is the zip file that we're going to get from the FTP server that is provided by python.org. Okay. So this is going to take a little bit. It already downloaded here. So that means that it puts it onto my download folder. And recall that this is a zip file. Sorry, the other one is done. So let me switch back here. Okay, so then what we're going to do is we are going to use a tar command, and tar command simply allows you to decompress the file. So you are going to do a tar xf, and we want to make sure that the file name is exactly the same as what we downloaded. So Python 3.9.1.tgz. If it is successful, you won't see any output. It'll just give you the drop, the next line for our terminal. But if you get an error, make sure you check your typo. So we already unzipped the file. We are now going to move into that folder that is unzipped. So you are going to change directory into the Python 3.9.1 that is unzipped. And notice here that I have the folder added to my path. So I'm in it. Okay. Then I'm going to do a /configure -- enable optimization with an S. This is required before you install Python for Linux. So what it does is it's going to check the system requirement to make sure that my system is compatible and capable to install Python, as you can see there. Okay, so most Debian release that you see out there, if you're using Mint or if you're using other releases, you're still going to have to bring in Python 3 because most of the Linux ship with 2.7 or none. Okay, so it's done. It's creating the configuration that I need for installation. Then I would install now the binary files. So I would do a sudo. Let me pull this to the right so you can see. Make all install. Make sure I have the right typing there. Oh, I forgot to add this. Sorry. Let me resend this up. I think you have to do a make J. I'll re-upload this. I forgot to add this one when I did this earlier. Okay, so we are going to do a make J-2, or I'm sorry, -J2. What you're doing here is you are setting up your hardware rules for the installation, because Linux is very, you know, like you can communicate with the terminal and use the command to access a little bit more on the low level. So what we're doing is we're going to create the rule, and if you have multi-core processor, you would make sure that this J is replaced with the number of core you have. So if I'm running an AMD and it's let's say 8 core and I want to give it 4 core, I have to enable it in VirtualBox, and I want to specify that here. So if you don't have anything, you just use a variable, and what that does is it creates a placeholder, and it's going to default to however many core that you have for your processor. Okay. So it's going to establish the hardware rule. And then after that, now we can do a sudo make I'll install. It's throwing me the okay, 1 second. Let me test this without. I'm double checking my step under documentation. Make J2. Oh, sudo make alt install. Okay, so I had a. Let me fix that command for you. Yeah, it didn't like the install together. Okay, I have a fix. All right, coming back to screen share now. Let me highlight that. Okay, so we're gonna fix the step 9 and 10. Sorry. Okay, so we're here. Okay, so we already did the make -J2, and that pertains to the processor. Okay, so instead of doing that, let's do this and this. Come on. Okay, it's better. So next we are going to do an alt make, sudo make alt install. It didn't like my alt rule. Okay. Sorry about this. Okay. Let me see if this works now. 1 second. Hash 1, 2. What's this version? Okay, I see why it's doing that. So you would be able to proceed. I had previously installed this, so that's why it's giving me the issue there. So let me share screen again and I'll tell you why. Okay. So when you do this step, you can simply do a make-j2, and then we would do a sudo make all install. You should be able to do all install or alt install separately like this. When you do this, it's going to build your binary file. So when Python packages come in and when you unzip it and access it, it is raw. So it has to build your file because it is an application. So it contains application libraries and all the components for the language. Okay. So when you get to here, it's gonna be able to set up the rules for your system, and then with that, it's gonna be able to build. Okay. Now Python uses an interpreter, but a lot of the times, if you dig a little deeper, you would see that the interpreter, it would use the C compiler underneath. So when it interprets line by line. You don't need to compile the whole program for Python, but your program would need to be built. And in Linux, we have GCC that's already enabled, as we would need that for our libraries in C for Python. So once you have to install, and the reason why it keeps throwing me an error is because I already have the version that's already installed. Okay, so I tried to install another one and it's telling me that it won't be able to build. So if you want to check your version, you can simply do a Python 3 -- version, right? And if you call on Python, it would just revert to whichever version that you had installed. Okay. All right. Any question? So check your version first. Let's see. Are we going to be using virtual? Yes. For most of our profiler, so this chapter, and then there will be additional chapters when we use when we do parallel and multiprocess and threads, you will have to use your virtual machine. So that way you can control how many processor that you dedicate to your application. The reason why I do this is because you can do a lot with it without having to impact your regular system. You can contain it into a virtual machine. We use it for testing, just like your virtual environment. So you can uninstall and install packages that you need, versus if you run the program on your regular system, it might impact your regular system. There will be time that we would have just regular IDE and you can run it. But when it needs a C compiler without using this, you would need to use Microsoft Visual Studio and set up your Python packages. But Visual Studio is not compatible with some of the libraries for Python. that is on the low level. So when we work with like some of the like async IO and other areas, you will need to use your virtual machine to test. So it would always be good to have a virtual machine. That's why I gave you one. Okay. All right. So once we have our Python installed, then we're ready. Okay. Now, if you want to run it on your regular system, yep, no problem. If you wanted to run this on your regular computer that you have Python and you want to use Visual Studio, you're welcome to do that. You can test it, but there are labs that I prefer that you use virtual machines so that way you don't have to go the extra step to set up your IDE for certain library. Okay. All right. So once I have my Python, I'm gonna make a folder so I can, the reason how you can move back to your home folder is to do a CD, right? Like anytime that you're in another subfolder, like earlier you saw that I was in the Python 3.9.x, I can type CD and it's gonna take me back to my home directory. And home directory is simply my student folder on home. So think of it like Windows PC documents for the user. Okay. So here, what I can do is I can make a folder for my lab. Make dear lab 2. You can have uppercase there. So I made a folder for my lab and I would move into it by using a CD. So that will be our step 13. So I want to be able to make sure that the folder contain all my file that I need. Okay. And then I would do a pip3 install, and the switch uppercase U here is to do an upgrade. So because sometime when you do an install, it's going to do the base package and then you got to update it. So we would just go ahead and make sure that it is the latest version. So let's do that. Install. Sorry, trying to zoom with virtual machine and documents at the same time. So let me move this up a little. And this -u memory underscore profiler. So what we just did here is we installed the library for memory profile. Okay. And if you've taken my classes before, you probably know that like I use everything in command line because I don't like to find and click and things like that. So in Windows, Linux environment, it's always good to like be in one place, but you can go and use your IDE and text editor and write this. But I'm going to show you how you can use your text editor directly in command line by using Nano. So we are going to use a tool called Nano, and Nano is also exists in Mac OS terminal. Nano is a way that we can open up a text editor and be able to create our script or our program. So when you use nano line profile.py, you're creating a text file, right? Or you're creating a Python file that through the text editor nano. Okay, so we are going to do line profile.py. So our text editor is empty. And I know that you probably want to show your line number because sometimes you might get an error and it tells you which line. Alt-C should be able to show you the column and the line. I think there is, for Linux, you can probably do like, what is that? Alt plus Alt and the number 3. There are many ways that you can also enable your line. So to write our program, we can simply start with the first line. So you can, I hate that. Let me re-enter that real quick. So up arrow key to repeat. And then add symbol. And then you are going to do a decorator called profile. Remember in the lecture, we talked about when we use memory profiler, we want to place the decorator at the section of where we are going to profile. Okay. So when you write your script, after you use the library, or you install the library, you would have the decorator, and then we would define our functions. So you would have def, and our function is going to be called memline. Let me see if I can change this to dark. Yeah, it's just gonna show. I gotta change the font, how it displays. But you would see the screen capture that we would have there. So in Python, you have to make sure that you indent. Okay. And so what we have is we have a variable A that is a local variable. We're going to have it to initialize at 1. And we're going to use the operator. And we're going to take 10. So we're simply using mathematical operations under this definition. Then we have B. And we would have 2. And that would be times 2 times 10, 7. And then we are going to do a del, so delete B, and we're only going to return A. Now, to set up our main, you would say if to underscore namespace is, right, main to underscore, okay. Then indent, we would say mem line. We would call the function. So once you finish writing, and this program is really short, it's tiny, right? And you would hit Control X on your keyboard. That allows you to go to this option. It's going to ask you, do you want to save? You're going to say yes. And is it going to be the same file name? So if you want to change up the file name because of the version, you can modify that here, but I'm going to keep it the same, right? And I'm going to go ahead and save. So I finished my file, and my file should be in lab 2. I can do an ls to see it. It's there. Okay. So now when you're finished, what you can do is you're going to execute it. And to execute it, we just simply call on Python. And we are going to make sure that we are using memory profiler. Remember that we installed it. And so this file, right? We want to make sure that our package is seen by the file, because if you had placed it elsewhere, you have to do an import statement. Okay. So I would then say Python 3-m. That's when you use Python. And you would say memory underscore profiler. I type it correct. And then my file name, line profile.py. So I have a syntax. So to go back to my file, I just have nano, right? Line profile. .py. If namespace is name. Okay, let me check it again. Okay. You need a space after. Yeah, I saw that too. After if. Sorry, when I have it on my Control X. Yes, that run. There we go. So when you get to this, when you profiling, what it's going to do is going to read line by line, right? And it's going to create your profile. So it's showing here that, you know, through the operations for the line, your memories usage, this is your storage. So if you wanted to check for your application, how much it dedicates the storage for each line for Python, right? When I delete B, it will be this. And then when we delete it, you notice that it gave back that space, and memory is dynamically allocated, right? And so as it finished the function, right, it gave back all the storage. So you would see how RAM is used, right? So this is how we would be able to use memory profiling for our application using line by line for that one function. So if you have a very intensive function, you can take a look at how your container use your storage, or look at your data structure in the storage. And then as it runs through that function or method, you would see the memory allocation. So as you complete the lab, this is what you want for the output. And so you would provide a screen capture. So as you know that when I use this, notice that my program didn't have an import statement, right? Okay, coming back here. Because the tool that I use, which is Memory Profiler, it's in the same directory as my Python file, I'm able to access it. But if you have a project that's stored elsewhere besides the same location of your tool, what you can do is you can add in, right, the import statement. So the second part to this, you can edit this file. So I can come back here and I would up arrow key to repeat, right? So we can go to line profile and we can move that down. We can add the statement and modify our program. Okay. So I can say from memory profiler import profile. And then in the decorator, what we can do is we can set the precision, which is the values or the places of decimal characters after my decimal period, right, to show on the memory output. So my precision would be 4. So if you want it to show less decimal character, you would say 2 or 3. So I put a comment there to be able to set the precision for the parameter. Our function is still the same, and we would still call the same function. So after that, we would then, once we modify our file, we would do Control X. And we want to say, yes, we want to update our file. And then again, we would just up arrow key twice to rerun the same file, but it has been updated. Okay. So now I have 4 places for decimal float here. My float shows 4 decimal places as the output, and my precision is set at 4. So it's still going to profile. What you did is you use the import statement so you can bring in the library components. So I brought in a module, right? Or part of the module, and then I would be able to still output the same, and I can control how it's going to be displayed as far as memory usage line by line. Okay. Any question? Okay, so take a screenshot, and then we are going to do some time-based profiling. And as you remember, right, this is the memory usage report is good, but we gotta make sure that we output some kind of file, or we can run the profile with this for the time. So for the memory usage report, we can use the time to look at the processes. And then we can also plot it to visualize it or whatnot. So here we can do an mprof run line profile.py, which we wrote. Oh. Oh, they changed it, so we would have to use gprof. Let me try their new command, because sometimes they change the command. Binary utility, development utility. We should use sprof. Let me check to see if we have to install additional thing here, because it was as they changed. Okay, so we will probably have to install this. So tells me sudo app install libc, so library C DevTools. And we put in our password. So I want to make sure that's correct. Okay, so the DevTools is in. Now we are going to try to see. So yes, to continue. As it runs through, let me see. So as they upgraded the Ubuntu tools, right, and you often see this in Linux. So if you want to run, so when I did this last year, I'm able to run the mprof and it's able to give me some kind of plot or output. And so if it's not able to do that, and it tells me here that they had changed that, so we would need to use sprof, and sprof require the lib tools, okay, the library C tools. Let's try it now. Okay, I will need to troubleshoot this, so I will omit that from your lab. Okay. All right, let's do timeit. So I think 25 and 26, let me see why it's not doing that, because sometimes they remove the tools and then now we have to fix it. So that's happened a lot in Linux. Okay, so timeit is a module, and we talked about this, and you can pull that from Unix time, use Unix time, and as we are in Linux, we can do Python 3 -m. And so what you're doing is you are testing the expression, right? So the simple way that we can do this is we can test it by looking at the execution. So we can have it to join, and we can range from start 0 going to 100. So here it's going to parse that into string, and then because n is actually a numerical value, so what we're doing is we're doing a dot join. So we're using this to test and using the timeit. So as you modify this, when you put it into the parameter, and then when you put it into a list container, and when you map it, it's going to be different. So let's try that. Timeit. Zero and or n in range, and that is 100. So when we run that statement, I have a message. Is lib DevTools or libc? Let me see my message. I'm sorry, libc.tools. Did I type that? clibc.tool? Yeah, I had. Okay, libc.tools. I typed it backwards. Sorry about that. We'll come back to that. So in that statement, when we have it through a loop for the 100 range, right? So here that allows us to send it through 20,000 loops, and the best of 5. Remember we talked about how we can specify how often it loops. By default, it's going to be 3 loops. So the best of 5, as it iterates through, it's 4.2 seconds per loop. So when you use the loop, you can determine, right, your best time, which is for 14.2 for the statement. Now, if you run the next one, we can do Python-m timeit, and we would do same thing. We would use a dot join. And in this case, notice that we would put it inside the square brace. And so simply changing that, right, we want to see if there's a difference in the time. So what I can do is I can come here, up arrow key, which gives me the same thing, but now I want to make sure that I put the square brace before the str. And I want to make sure that I close it after the first parenthesis. Like this. And I would run it. So when we put it inside a container, it actually gives us some improvement, about 1.2 seconds. Now, when you run it on your system, even though we're using the same virtual machine, you're going to find that it slightly is a little different than mine, or it could be the same, because again, we have different processor, right? And different hardware that we're running our virtual machines. So it's going to give you a little different time. So for my first one, I have 14.2 seconds. My second statement, I have 13 seconds. And then I would then change my str to map. And instead of the for loop, I would be able to pass the range in the str. So I would change this. So that will be map str. So when we got to here, when we're using the map method, it's able to map your data to the location of memory. So it shaved off from the original time about 4 seconds. So in the chapter and in our lecture, we talked about how we can rewrite the code multiple times and think about how you use, right, your data structure or your tools to be able to improve your program performance. And we simply see that it is the same thing, okay? But we simply change it up. So from just a regular for loop where it would be very linear, it's going to go from one to the next to the next. That's 14 seconds, 14.2. And then when we change that and we put that into a list container, it shaves off by 1 second. So we see that it is going to be, because in a list, right, it's going to sequentially access it the same way, but we would organize it into a location on the memory. So it is a little faster. Then now if we put that, it's still going to be the range of 100, but if we put it into the map method, it's able to map the location of where the data would be quicker, and it definitely shave off 4 seconds. So that will be, and again, it's tested through the best out of 5. So I get 10.7 seconds for that last round. So this is going to be the best of the statement. So what this shows you is that as you modify it, you get different time output, where we would use the expressions similarly, but we simply use the timeit, which exists in Unix and Linux. Windows doesn't have it, so if you use it in Windows, you would probably have to bring in the module. You have to install it and make sure, but this is equipped with Linux. There are many things that comes with Linux, so this is why we're using the virtual machine. Any question? Let me come back to here and let me retest this. Yeah, when you do let me fix that later. So if you can't finish 25, 26, that's fine. But 27 and 27 should work. Okay, question. It says that I have low disk space on Ubuntu. You do? Oh, in here? I had set it for 50 gig. Did you create your virtual machine or are you using the one I released? Okay, so likely that you had used the default disk size, which is 10 gig, and 10 gig is too small. When you're running programs like these, right? So 10 gig is like the base. When you add anything else, it's gonna tell you that it's running out of space. So think about Windows PC, it's like using a 10 gig C drive, right? It's just barely enough to run the OS. So what you want to do is you want to, if you want, you can recreate the virtual machine. You can probably size it up. There are instructions on virtual machines on how you can size up your disk drive, modifying the vdisk image, but it's probably like faster to just recreate another one and then reinstall and so on. But you can do that for a while. Eventually, you're going to have to keep deleting programs and be able to do this. So yeah, I ran into that last year. So that's why I use 50 gig. Yeah, so make it like 50 or 80. That's safe. That's only going to be like less than 15 gig or about 15 gigs in your, yeah, it's just the base. So just run enough for the OS. So I would recreate it. Okay, so next we are going to do the KCacheGrind. And you can be in the same project folder, right? Your lab 2, and you would do a sudo app. Let me move this over here so you can see. Let's put this up a little. Git install KCache. Right. I'm gonna make sure I type everything correctly. And so remember that this is graphical user interface. It does take up a lot of space and resources. So when we're done, we can also do a remove. So we're going to install, and this take a few minutes. Then after this, you are going to, you can do a pip3 install. You might not even have to use that, but if it prompts you that you don't have privilege, you have to put the sudo in the front. Okay. So when we're finished with CacheGrind, we are going to use the cProfiler. This is required with CacheGrind. CacheGrind is just a graphical user interface that use cProfiler to give you these little small boxes to show you, right, how your application would look. Okay, so it gives you the visualization on how that would be. Okay, so that's done. I'm going to go ahead and do an install for pip. Let's just do sudo pip3 install cProfile v. Okay, so what that does is it's installing the cProfile for me. Now, after I had done that, then I would install the third component, which is covered in your lecture or your notebook. Is gonna be our pyprof to call tree. So earlier, notice that we were trying to profile using prof or gprof, which is a graph, and that didn't work because sometimes if we don't have the right packages, it won't be able to pull. So sudo apt install. Now we're going to do a pyprof. See if we can pull this a little more. Pyprof to call tree. So as we brought in that tool, now we can call on Python 3-m and you can do a cProfile. And we're going to output like what we talked about in the assignment prof. We're going to output a file called prof. Prof.out, and it's going to profile line profile.py, the first program that we wrote and we also edit. Okay. So now we can convert by using pyprof to and call tree. Maybe I had a typo there. Okay. So make sure that we run this. And we're going to do a switch I pop out. So it's going to convert our file. And we're going to output that as a prof call tree file. So what that does is it converted, right, the file that you created with cProfiler to the application. And then from there, you can use the application to access it. So you can be able to have the visual of it instead of it being in a file, we can use the file to be able to put it into the application to show on graphical user interface. So what we would do is we would do a KCacheGrind prof.callTree. Or KCache. Prof.callTree. That didn't want to go. Let me see. KCacheGrind. We'll open to command. KCacheGrind. Sudo. Linux module extra headers following package automatically install no longer required. Newest version. KCacheGrind already exists. Let me test. There we go. So after that, you really don't need to use this right here. I'm going to highlight it as optional, right? Because I remember that it should work. So if you call KCacheGrind, the application should open, or you can search for the application. It should already been installed and you could close. So to open your file, you can simply go to student, and then that was lab 2, right? To be able to import, but I'm fine with you getting here. So this command, this command should be able to output the file for you, but when you import it in, you simply bring that in. So I don't think you need this part right here. So let me re-highlight this. No color. So what we can do is we can just use, so let me try that again. So it should open up the application. So when you close it, it gives you back your terminal. Okay, CacheGrind. Oh, that country. Yeah, it wanted additional packages. It's not seeing it, but then we would just need to open the application. So here, simply use KCacheGrind. And then it walks you through on how you can set up your function or your file for color and calling map. So as you know, if you work with the function for C, you would have a callie and a color. So it's able to map that to the location when it puts that on the stack. So when it executes, it puts your variable into a location of memory so it can access it. So this is how it's going to be able to map it for you. Okay, so here it gives you like the startup on how you would be able to use KCacheGrind. And sometime if you have an intensive application, it does take a while to go. Okay, so here I don't have any file that's loaded. So I can go and find like it needs to be a prof call tree file. So if you successfully output this, you can try to locate the prof.call tree to be able to visualize it. Okay. Any question? Let me try that again. Hold on 1 second. Let me see if it sees the, oh, it's using the dot out. Yep. So you just have to change it. So what I did was I click open, go to student. That's who I am logged in under. Go to lab 2, that's our folder, and you don't see anything here. So you just go down to all files, and we converted the prof call tree with the step 33. So you can select that and then click open. Okay. And it should give you this. So here you would see like some of the called information, the function information, which module it's used to be able to see that, and so on. So this gives us the graphical user interface of our program that we wrote in the first few steps, your line profiler. Okay. Any question? So you can test it with other Python program and see. And, you know, after a while, you would be able to, you know, use more of this tool. There are many features for this, but this is just like I'm showing you the basic on how to be able to access it. Okay. Any question? So I'll add that step here instead of this. Open application by using in terminal, and you just simply call KCacheGrind. And once that open up, click file and then navigate to student folder, then to lab 2 folder, and find and select. Which one was it? Prof.call tree. Close your tip of the day, and then you should be able to take a screenshot. Okay, so there you would see how you can access your profiler, your profile information from an application. You also did memory profile. The only thing, and then you also use timeit module to look at your time. We didn't do the memory profile directly from using run command, but we were able to do that previously. So I got to investigate why this stopped working on the new release. But you were able to do line by line profile and use memory profile. So that gives you a little bit more understanding on how to create profile for your program. Any question? Okay. All right. So I'm going to go ahead and stop recording.